Here let me define the position vector, which I am going to use many times. This is y-axis. For motion in a plane I am discussing. Here is the object. So this is r1 bar. So r1 bar is equal to x1 I cap plus y1 j cap, and in time t it follows this path and come to this point. So this position vector is r2 bar origin. r2 bar is equal to x2 I cap plus y2 j cap, and we know displacement is equal to r2 bar minus r1 bar, and its direction is always from initial position to final position, that is s bar. Or vectorially also you can verify r1 bar plus s bar is equal to r2 bar from vectors addition. r2 bar is equal to r1 bar plus s bar. So s bar is equal to what you can write? r2 bar minus r1 bar. Now path length. Path length means length of the path followed by the object. So this is the length of the path followed by the object. So in this way we can discuss about the displacement and path length as far as motion in a plane is concerned. And what about motion along a straight line? See here, this is x-axis, this is y-axis, this is origin, here is the object initially at plus 5 meters, let me take. Now this is initial position of the object, so this is initial position vector r1 bar. Next it come to here, and this is final position vector, that is r2 bar. So displacement is equal to, let me take this as minus 10 meters. That means r1 bar is equal to 5 I cap, y coordinate is 0, z is 0, and r2 bar is equal to minus 10 I cap. So displacement is equal to r2 bar minus r1 bar, that is equal to minus 10 I cap minus 5 I cap. This is r2 bar minus r1 bar, so minus 15 I cap, and its direction is again from initial position to final position. So this is the direction of the displacement. And as far as path length is concerned, here it is starting, so length of the path is also same, but path length is a scalar quantity, so we have to express only magnitude but not direction. Minus I cap means it is along negative x-axis. Let me introduce two terms. Those are rest and motion. When we are going to use a rest term, when I am going to use motion term, frequently I am going to use this rest and motion. So what do you mean by rest? What do you mean by motion? See, this is road. The vehicles are moving on this road. Here is one tree, and here is the person standing by roadside. Now he observes the tree and say that the tree is at rest, and he observes the car that is moving on the road and answer that the car is in motion. So according to this person, the tree is at rest. According to this person, the car is in motion. Then how is going to answer this? So in kinematics we are going to define a reference frame. A reference frame means a coordinate system that we are going to assume at the person who is making calculations, who is answering, and we assume this person at origin of the coordinate system, and we take the position vector of the tree with respect to this coordinate system, and with the time the position vector of this tree is not changing with respect to this person, then this person say that this tree is at rest. That means position vector of the tree with respect to this reference frame, coordinate system is also called as reference frame. So position of this tree with respect to the reference frame attached to this person does not change with time, then the tree is said to be at rest. Suppose if we take the position vector of this car from origin of the coordinate system, when the car come to here and its position vector is changing, that's why this car is said to be in motion with respect to this reference frame. And let me take one more example. Here is the bus and the driver is driving the bus, and here is the passenger is sitting inside the bus. And in some time, if the bus moves from this place to this place, here is the driver and here is the passenger, passenger. Now with respect to this passenger, you can take this coordinate system, means this reference frame is called passenger reference frame, and you take the position vector of this driver, and with respect to this coordinate system, the position vector of this driver is not changing with time, so the passenger answers that the driver is at rest. If you consider any person, so here also position vector is not changing with respect to this reference frame. That's why with respect to this passenger reference frame, the driver is at rest only. Suppose if you consider the person who is standing on the ground, and with respect to his reference frame, if you take the position vector of the driver, the position vector of the driver is changing with time with respect to this reference frame. So with respect to this reference frame, the driver is said to be in motion. You can ask me one question. Okay, you are saying that passenger, with respect to passenger frame of reference, the driver is said to be at rest because position vector of the driver with respect to this reference frame is not changing with time. Okay. The driver is in motion with respect to the reference frame attached to the person who is standing on the ground with time. That's why the driver is said to be in motion with respect to this reference frame. Now about the driver I am talking, but I am giving two answers. One time with respect to the passenger reference frame, the driver is said to be at rest, and with respect to the reference frame attached to the person on the ground, the driver is said to be in motion. So about the driver only I am giving two answers. So you can ask me one question, which is correct? Just to tell me whether the driver is at rest or motion, I can't tell. Why? Because as per the observation of this passenger, the driver is at rest is correct. As per the observation of the person on the ground, the driver is motion is correct. That means with respect to this reference frame, the driver is at rest is correct. With respect to this reference frame, the driver is in motion is also correct. That means rest and motion we are going to define when we specify the reference frame with respect to which we are going to define the rest and motion.